Hello. Let's start today's daily lead code problem. So the problem, as you see, is 2435 paths in a matrix. We have already solved it. Let me just maximize the problem. Okay. So we are given a zero index matrix which can be m cross n, and in that matrix we'll have an integer k. So what we have to do is we have to reach the kth position from start to end and the sum, that is the cost of the path if it is divisible by k. So if it is divisible by k, then it should be added. So we have to return the total number of paths that are like this. Total number of paths. So how do we approach this problem? So the brute force method, let me just erase this. So the brute force method will be, we'll go like this first, calculate the sum for every node, then we'll go like this next, calculate the sum for every node, then go like this, calculate the sum for every node, go like this, calculate the sum for every node. But this is not the most optimum solution. This is just the brute force solution. So let's try to calculate how many paths would there be. So here we have 3 rows and 3 columns. So the number of paths that are possible will be, and we are allowed to just move down or right. So we have down right options, we have 3 down options. Among these two will be our starting point, this will be our ending point. So according to this, what will happen is we have 2, 4, that is the total option, which is m minus 1 plus n minus 1. These are the total options, and among these options we will be selecting some n minus 1. So this will give us the total number of paths. Total number of paths. Let's check over here. So we have 3 cross 3 matrix, which will give us 2 plus 2 C2, which is 4 C2, which is 4 into 3 by 2, 2, which is 6 paths. So we'll have a total of 6 paths in this matrix. Now for this matrix, we have 1 plus 0, C, 0. So here we'll have 1 path, that is just this path. Next, okay, just a minute. Next, suppose we have this as 4, 3. So we'll have 3 plus 2 C2, which is 5 C2, which will give us 5 into 4 by 2, that is 10 paths. So what could be the logic? So if we go for the brute force, we'll calculate each and every path that is there. So this path, this path, this path, this path, then this one. We'll calculate the sum for each path. What we can do over here is we'll use dp. How will we use dp? We'll store the cost to reach this path. We'll store the cost to reach this path. We'll store the cost to reach this path. Now If it would have been the total cost, then it would have been very large. Now what we can see over here, the k ranges from 1 to 50, and what we need is over here, we need the paths that are divisible by k. What we can do now is we can have an array. Let's name our array dp. So what this array does, what this array will have is m cross n will be the amount of rows that is going to have, and then we'll have k. Why do we have k? Is because the remainder will span between 0 to k. That is why we have k over here. Now next thing, so if now let's try to have a loop for I. Now our I will range from 0 to m. Then for j, our j will range for 0 to n. Now over here, what we can do, if I, just give me a minute, if I is 0 and j is 0, we will just increment the numbers remainder, number percent k plus plus of the dp array, where I is 0 and j is 0. If only the I is 0, look, if only the I is 0, what happens is, if only the I is 0, what will happen is the cost will be nothing but the last wale ka cost plus apna cost. So what will it be? The dp will be equal to I j and the num percent k. ठीक है, num percent k. So over here, the dp will be, we'll have to loop from our pointer will range from 0 to k. So why does our pointer range from 0 to k? It is just because we need whatever remainders that were over here, whatever paths that were there, we need to check if pointer is greater than 0. If the pointer is greater than 0, then we will do what? We will add the num to it, add the num, take the remainder, and once we have the remainder, the dp that is there, we will increment for that I, j and ptr. This is if I equal to 0, and we will check the ptr for dp of I j minus 1. ठीक है, because the I is 0. Next, if j equal to 0, then we will have to check I minus 1 for ptr greater than 0, and once we check for this, we will increment the dp I j and ptr plus num percent k equal to So dp of I minus 1 j ptr. ठीक है. Now once this is done, let's try for the center wala ye. For the center same thing will be there, only the change will be if we are the center one, that is not one of the 1 and 2, else what do? We check for pointers again, and then for this guy we'll add. If it is greater than 0, then dpi j ptr num percent k, ptr plus num percent k. ठीक है. This value will be taken plus equal to dp of I j minus 1, and then ptr ka value will be added. The same goes for again ptr 0 to 50, dp I j, same ptr num, ptr plus num percent k, but this plus equal to will be for dp I minus 1 j and ptr. Let's write the complete algorithm now. So for the complete algorithm, what we'll do is first check. First we'll have a dp which will be m cross n cross k. Now once we have this dp, first thing will be a for loop. Well I will run from 0 to m. Another for loop will have j which will run from 0 to n. Now here we start the conditions. If I equal to 0 and n, j equal to 0, we will just have the dp which is which is I j and num percent k plus plus. Why? Because here we'll have int num equal to grid I energy. Else if I equal to 0, we'll have a ptr ranging from 0 to k, and if we hit another ptr which is greater than 0, that is the sum existed, then what will we do? We will have the dp I but just give me a minute. Wait. If the dp of now I is 0, so we'll have I j minus 1 and ptr. Yes, is greater than 0, it means the sum already existed. Then what we'll do is dp I j ptr plus num percent k equal, so this will be plus equal to dp of this, dp of I j minus 1 and ptr. else if j equal to 0, then for ptr ranges from 0 to k, what we will do, if dp over here we'll have I minus 1 j ptr greater than 0, then we'll update the dp ptr plus num %k plus equal to dp I minus 1 j ptr. Else, this else is nothing but this, the one where the top and the left both can come. Else, so we'll have these checks again, the same checks. If dp I minus 1 j ptr greater than 0, then we'll have dp I j, so this we will add here for an I minus 1. Here we'll have a for loop where ptr ranges from 0 to k, and in that the second one will be dp I j minus 1 ptr greater than 0, then we'll have dp I j again ptr plus num %k plus equal to dp of I j minus 1 ptr, and in the end what we will return will be dp of m minus 1 n minus 1 and the pointer 0. So this will return nothing but the sum of the paths that that have the cost to reach from origin to destination equal to 0. Sorry. Destination divisible by k, that is the remainder is 0. Thank you.